Welcome back to Hardware Unboxed. Today we're taking a look at the second Apple Silicon product we've ever benchmarked on the channel, Apple's new M2 SoC they've integrated into the MacBook Pro 13. Once again, a huge shout out to our Patreon and FloatPlay members who support the channel directly and allow us to buy products like this because Apple would never sample them to us. Like our previous look at the M1 Pro, this isn't a laptop review. We aren't going to evaluate the MacBook Pro 13's credentials as a laptop. I believe it's been copying some criticism for its outdated design, but I'm not concerned about how it looks. Frankly, I couldn't care less. Instead, I'm more interested in how the Apple M2 performs across a selection of cross-platform applications, so we can compare it to the best parts available in Windows machines of this class, like the AMD Ryzen 7 6800U and Intel Core i7 1260p that we've recently been testing. Apple has been touting this new M2 as much faster than its competitors, but Apple, like most companies, aren't exactly reliable when it comes to in-house benchmarking, so we'll have to see for ourselves. The M2, like all Apple Silicon products, uses the ARM architecture family instead of x86 that we see deployed for the vast majority of Windows systems. The CPU portion includes 8 cores split into a 4+4 layout, 4 high-performance Avalanche cores, and 4 efficient Blizzard cores. This is the same 4+4 configuration as the M1, but with the updated cores. And it contrasts to the M1 Pro and M1 Max, which use more performance cores but fewer efficient cores. That's because those chips are designed for high-performance productivity systems, while the M2 is destined for ultra-portable machines. The performance cores are clocked up to 3.5 GHz, slightly higher than its predecessor. As for the integrated GPU, there are 2 configurations available, one with 8 GPU cores and another with 10 GPU cores. We're testing the 10-core variant, so the highest M2 configuration you can get. On the memory subsystem, it's LPDDR5 6400 over a 128-bit bus, providing just over 100 GB per second of bandwidth, an upgrade on the M1 that used LPDDR4X, but without as much LPDDR5 bandwidth as the M1 Pro and above. The M2 also receives Apple's powerful Meteor Engine and Neural Engine. For testing today, I've purchased a 13-inch MacBook Pro with the full M2 configuration. I've also chosen 16GB of memory to match other systems that we've tested, and opted for a 512GB SSD because the base configuration that only has a 256GB SSD is a bit ridiculous in 2022. Like most Apple products, upgrading to high memory and storage configurations costs a really disgusting amount, and there's no user upgradability to speak of. For testing today, we'll be comparing the M2 to our existing data for AMD and Intel CPUs, which is all power normalized to the default TDPs of those chips. There are, of course, some challenges here, namely that not all applications we benchmark are available on macOS, so we're only including cross-platform benchmarks with a macOS version, whether that's a native ARM version or an x86 version emulated on Apple Silicon via Rosetta 2. At this point, though, the majority of apps we test have a native Apple Silicon version. This immediately introduces a variable in that Windows and macOS versions of apps will work slightly differently, but it's the best we can do given the circumstances. So let's get to the testing. I'm going to start here with the power numbers because these set the expectations for the performance benchmarks we have coming up. In Cinebench R23 multi-threaded, I recorded 23 watts of power draw from the wall after subtracting the idle power usage of the system. This puts the general CPU package power between the 2 configurations of the Ryzen 7 6800U that I've tested, at 15 watts and 25 watts. What this suggests to me is the M2 is most equivalent to a 20-watt configuration when the CPU is heavily utilized, which is a typical number for an ultra-portable 13-inch notebook. The M2, like the M1 Pro, is extremely impressive in how little power it uses for single-thread applications. While the M2 is slightly more power hungry than the M1 Pro due to a small increase in frequency, it's still using far less power than the next best configuration. We're looking at less than half the system power of the 6800U and an even larger gap to the Core i7 1260p. The fact that this ARM chip only clocks up to 3.5 GHz versus 4.7 GHz for the AMD and Intel chips has big implications for efficiency, as most process nodes are better optimized for mid 3 GHz frequencies than anything above 4 GHz. When gaming in Shadow of the Tomb Raider and hitting both the CPU and GPU, the M2 consumes somewhat more power than when we're just utilizing the CPU heavily. The M2 is now most equivalent to the Ryzen 7 6800U running at its highest 25-watt power configuration, though the M2 is still using less power than Intel's Core i7 1260p at 28 watts, and generally there's no issues with this level of power. Modern laptop designs are more than capable of running in the mid 20 watt range, and the MacBook Pro 13's cooling is good enough that the fans rarely have to activate, though on occasion I did notice the fans running at a high RPM, usually during the heaviest workloads. Let's kick off the performance benchmarks with Cinebench R23 multithreading. In this workload, the M2 puts up a reasonable showing, matching the Core i7 1260p despite running at a much lower power level. Compared to AMD processors, the M2 is similar to current gen parts in both performance and efficiency. The power consumption level is between the 15 watt and 25 watt configurations of the Ryzen 7 6800U, and so is the final performance. What we're seeing is Apple can keep up with today's best mobile processors, but not exceed them. In the single-threaded test, the M2 is very competent. A score of 1580 points exceeds that of the M1 Pro and also beats the Ryzen 7 6800U by 9%, putting its performance more around the mark of the Ryzen 9 6900HS. However, despite an upgrade to the core architecture, the M2 is still beaten by Intel's Alder Lake lineup, including the Core i7 1260p, which is 8% faster in this workload. The only way Intel is able to achieve this is via high clock speeds, which push up power consumption. As a reminder, we just saw the 1260p single-thread power consumption is over 3 times higher than the M2, and AMD isn't much better, using over twice the power for slower performance. The M2 is not very good at CPU-based video encoding in Handbrake. This is a heavy multi-threaded task that utilizes AVX instructions on x86 processors, which do appear to give them an advantage over Apple's ARM products. The Ryzen 7 6800U in its 15 watt configuration is 17% faster despite using less power, and several other parts are also superior, including Intel's 1260p. As a reminder, this benchmark specifically does not use hardware accelerated encoding. That's not the point of this test, as we wouldn't be testing CPU performance, and the final output would be different for each product due to the quality differences of each hardware encoder. A few people commenting on the M1 Pro review seemed a bit confused by this, but basically testing hardware encoding properly is very difficult if you want a fair comparison, because the fastest encoding settings often differ widely in output quality. And in any case, if you wanted to perform hardware accelerated transcoding, you shouldn't use Handbrake. I'd recommend DaVinci Resolve, which in my testing is consistently faster. Using DaVinci, the best I can say is that hardware encoding performance is similar between each CPU, but it depends on the quality settings you choose. In Blender, we've shifted to using version 3, the latest version, and the new Open Data benchmark that goes along with it. That means we've only tested a small sample of processors so far, but we can still learn a few things here from the CPU encoding variant of the benchmark. The M2 here is very similar to what we saw in Cinebench, noting that both applications are native Apple Silicon apps now. The M2 sits closer to the 15 watt version of the 6800U than the 25 watt version, but nevertheless outperforms the 1260p. It's a different story for GPU encoding. In this productivity test, the M2 is quite a bit faster than the 6800U, coming in 41% ahead. AMD's graphics have been historically weak at a lot of productivity-based work, but whether it's raw performance or optimization, the M2 has a large advantage here in the ultra-portable class. In MATLAB, the M2 performs very similarly to the M1 Pro using the built-in benchmark. This is one of the last remaining apps that doesn't have a native Apple Silicon version, so emulation is required here, and that hurts performance. The Core i7 1260p ends up 12% faster, so I guess it's not terrible with emulation, but I suspect it could be better were this app native. In our Microsoft Excel benchmark, the M2 is quite fast, slightly outperforming the M1 Pro in what is a good test of the CPU's cache capacity and performance. The M2 is 6% faster than the Ryzen 7 6800U and 21% ahead of the Core i7 1260p, placing it in the lead among ultra-portable class processors that we've tested. 7-zip compression is another strong result for the M2. While here it's not close to the M1 Pro with its 8 performance cores, the M2 is still able to beat the Ryzen 7 5800U and 6800U by 10%. The Core i7 1260p is even further behind, putting in quite an unimpressive result. However, for decompression, the story is flipped. Now it's the M2 that is the least impressive part of the current generation models. The 6800U is a real beast in this workload, delivering 53% more performance in its 25-watt configuration. The 1260p is also 19% faster, though this looks less impressive given the 1260p uses more power than the M2. The AMD CPU does as well, but at least you get a big improvement in performance there. Since we last tested Acrobat PDF exporting, Adobe has updated the app with native Apple Silicon support and performance improvements on all platforms. This makes our exact same PDF to PNG export run a lot faster now, which warrants a retest. In this workload now, the M2 is pretty close to other competing CPUs in what is still a lightly threaded task. However, the 1260p is 7% faster and in the leading position, while the 6800U is 4% faster. Not earth-shattering margins, so like I said, close between these parts. In FL Studio, it's also relatively close between the M2 and other mobile processors, although the M2 is the slowest part of the latest gen CPUs that I've tested. The Ryzen 7 6800U is 16% faster in this workload when configured at 25 watts and 12% faster at 15 watts, while the 1260p is 6% ahead. Among integrated graphics solutions, the M2 is a beast for Adobe Premiere, and this is really where the accelerators that Apple are using show their strength and power. In the overall score, the M2 crushes low-power models like the Ryzen 7 6800U and Core i7 1260p, outperforming 45-watt CPUs like the Core i9 12900HK. A lot of this comes down to the extremely strong live playback performance thanks to hardware acceleration for popular editing codecs like ProRes. But even for exporting, the M2 is an excellent choice, delivering the performance of an integrated GPU 45-watt solution at just 20 to 25 watts. Premiere performance, and by extension other video editing apps, are a massive selling point for Apple Silicon devices. The M2 also performs strongly in gigapixel AI image upscaling, though not as well as the M1 Pro or laptops that use discrete NVIDIA graphics, as you can see from the chart. As far as integrated GPU solutions go, the M2 outstrips the 1260p by a slim margin. Both CPUs here include hardware accelerated AI processing. The 6800U at 25 watts, which does not include AI acceleration, falls behind and ends up 8% slower, which isn't a terrible result, as the GPU I guess is still a good fallback. Our final productivity workload is Agisoft Metashape, a photogrammetry benchmark which is mostly run on the GPU. Here the M2 again flexes its muscles, completing the task 27% faster than the Ryzen 7 6800U at 25 watts. That's not as much of a margin as in Blender's GPU accelerated benchmark, but still a substantial difference, given both products are running at roughly the same level of power consumption for GPU accelerated tasks. As for gaming, you probably shouldn't choose a Mac for gaming, as the majority of games are not supported on macOS, and many more simply can't be run at all, even through emulation. But one game that can be run is Shadow of the Tomb Raider, which allows us to get some basic gaming numbers. Running using identical quality settings, the M2 is slightly faster for playing this game than the Ryzen 7 6800U when both are running at a similar level of power consumption. Looking at average frame rates, the M2 is 8 to 10% faster, which is quite impressive given how powerful the RDNA 2 graphics is inside the 6800U. In terms of battery life, this is one of the most impressive aspects to the MacBook Pro 13's performance. In our YouTube 4K playback test in Google Chrome, the M2 powered system lasted over 40% longer per watt hour than the next best system that used the 6800U. And we're using per watt hour metrics here to normalize for battery capacity so that larger batteries aren't significantly influencing the results. This does give the Mac a definitive lead in battery life for this test, and most applications in general. It's hard to deny that the battery life is very strong from this laptop. It also benefits from not dropping performance on battery, which often when you're using an AMD or Intel powered system, you will see lower performance when run on battery, but this isn't the case with the MacBook, which is again quite a strong result and points to its strong efficiency when run on battery. Like the M1 Pro when we looked at it last year, the Apple M2 is a very interesting processor that provides something different to the usual parts from AMD and Intel that we test. There's no doubting it's a strong performer in a number of areas, but it doesn't always have the edge that you might expect, especially if you're prone to sloping up the hype. The CPU, comprising 4 performance and 4 efficient cores, is certainly quite capable, but is perhaps the weakest area to the M2's package relative to the current crop of x86 laptop parts. Across the dozen or so productivity benchmarks we ran, multi-thread performance was typically around the mark of AMD's Ryzen 7 6800U, while single thread was between the 6800U and Intel's Core i7 1260p, though of course results did vary depending on the workload. The M2 has a good balance between multi and single thread speed, but doesn't deliver the outright best performance in either category. To me, this was somewhat surprising given Apple's node advantage, with this chip being built on TSMC 5nm, a generation ahead of what AMD and Intel are currently using. I was hoping this would bring class-leading CPU performance. However, other areas are very strong. GPU performance is impressive, beating the Ryzen 7 6800U's integrated RDNA 2 graphics and offering capabilities more in line with a low-power discrete GPU, especially for productivity tasks. While I don't think the M2 is a great gaming platform due to its lack of game compatibility, this SoC in its 10-core variant is very impressive in workloads like Blender or Agisoft Metashape that are GPU accelerated. It should be noted that to achieve this performance, Apple are using quite a lot of transistors, 20 billion for the M2 versus 13.1 billion for the 6800U, so I guess that result should be expected to some degree. The best area to performance comes when all of Apple's accelerators can be used in tandem, and that's usually the case in video production tests where the M2 is at its best. For video creators, I think it's hard to beat thanks to features like ProRes hardware acceleration, its fast GPU, and relatively low power consumption, which allows for near silent use while editing. macOS also has a good ecosystem of video editing apps, so this is definitely the strongest use case I can think of for M2 powered laptops. But for a lot of other productivity tasks, especially those that are more CPU limited, I don't think the M2 gives a significant advantage over x86 processors of today. Bringing everything together is excellent efficiency. Single-thread performance per watt is astoundingly good and destroys its competition, while multi-thread CPU efficiency is around the mark of AMD's Zen 3 parts, and GPU efficiency is also very strong. With these sorts of results, the MacBook Pro 13 is comfortable in not reducing performance on battery, whereas most Intel and AMD systems will throttle down the available power to conserve juice. This leads to both excellent performance away from the charger and excellent battery life. x86 CPUs have a fair way to go to match these sorts of capabilities. So what are the downsides? Well, to access this level of performance and efficiency, you'll have to fork out a lot of money. While the MacBook Pro 13 starts at $1,300 US, that's for a configuration with way too little memory and SSD space. To get the model we tested with 16GB of RAM and a 512GB SSD, which is what I feel is kind of the minimum you should consider for a part this powerful, you're looking at spending $1,700 US, which is certainly a lot. The MacBook Air coming shortly is no different either. In contrast, the Asus ZenBook S13 OLED we tested to get our Ryzen 7 6800U performance data, that laptop is $1,300 for a configuration that actually has a larger SSD than the MacBook we tested. This makes opting for a MacBook 30% more expensive than a very decent Windows laptop. The other downside is macOS and the general Apple ecosystem. You might think differently, of course, but when we polled our primarily Windows-using audience a year ago on whether you'd consider switching to a Mac, nearly half of the 271,000 responses said they'd never consider switching ever, and a further 36% said they would need to be substantially better to consider. This presents quite a hurdle for Apple in getting users to switch over, at least for enthusiasts that watch channels like ours and care about Apple Silicon versus x86 performance. Whether or not the results you've seen today count as substantially better is up to you, but personally, I tried using the MacBook Pro I bought last year for testing the M1 Pro, and despite its excellent performance and battery life, I ended up switching back to Windows after about 2 months, purely because I very much prefer Windows as an operating system to macOS. But if there was an effective way to run Windows on MacBook hardware without destroying its capabilities, I'd certainly consider switching to Apple hardware, because the hardware package that we're talking about with the M2 processor, its efficiency and performance is very impressive, and that's the sort of thing that I would consider using. What I am curious to see is how the x86 chip giants respond. I expect to see new processors from both brands in around 6 months, probably around the start of 2023, and at least for AMD that will bring a significant step forward to using TSMC's 5nm node, the same as Apple is currently using. How the M2 will fare compared to next-gen chips without a node advantage will certainly be something to keep an eye on, and I'm keen to see what improvements AMD and Intel can get from next-gen parts. Anyway, that's it for this look at the MacBook Pro 13 and the M2 processor. Again, very interesting range of results. Some things impressive, some things pretty much as expected. If you are interested in supporting the channel and the testing that we do among laptops, desktop parts, and monitors, then do consider supporting us on Patreon and Floatplane. You'll get access to things like our monthly live streams, our Discord chat if you want to discuss these results with some of our members, and all sorts of other good perks. So thanks for watching, and I'll catch you in the next one.